Excellent.
Hey, what's up, folks? Welcome back to another 3D Hangouts. My name is Noah Ruiz. I'm a designer here at Adafruit. Joining me every week is my brother Pedro.
Good morning, everybody. I'm Pedro Ruiz, Creative Tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
That's right. This is where we combine 3D printing and DIY electronics to make Kitty Paw inspired projects. Hello, everybody. Welcome to the chat room. The show. We're hanging out in the chat room, the Discord server here. If you want to get an invite to that, you can head over to discord.gg/Adafruit. We're hanging out in the live broadcast chat room, and we want to take a moment to thank everybody for joining us live. It's really fun that we have a live kind of audience going on here.
Giving shout outs to everybody hanging out in all of the chats. We are hanging out in the YouTubes. Good morning, Gary, Patrick, Mr. Certainly. Bruce is hanging out in both that and the Discord. Where's my Discord? Good morning, Rolves. Morning, Yanni.
Morning,
Stuart
morning,
Riggs.
Morning, Stuart.
Jim Hendrickson.
Morning, Jim.
Vince.
Vince.
Good morning to everybody hanging out. Thank you all for joining us.
And I believe we saw Bruce in the YouTube chat as well. So if you want to say hello, ask any questions throughout the show, we'll be checking back in with the live broadcast chat room. That's where we're hanging out.
Morning, Randall.
Yeah. And shout out to all the other thousands of folks who have joined the Adafruit Discord community. Cool. I'm going to do some quick housekeeping as we do in the mornings, and then we'll jump right into this week's project. So first up, the CircuitPython meeting happened yesterday, because Monday we had a bit of a holiday, or it was a bit of an extended weekend. So Monday, normally we have the CircuitPython meeting, but this time it was Tuesday. Before you check out the archive that is posted on YouTube and other podcasting softwares. Cool. The newsletter happens once a year. This is the once a week newsletter. If you want to be up to date on all the new things that get added to the Adafruit shop, happens once a week. You can subscribe to this, adafruit.com/newsletter. And for daily newsletters, if you're interested in categories such as maker business, 3D printing, Python on hardware, you can subscribe to these daily emails by heading over to adafruitdaily.com. You can choose all the different categories as I rambled off some of them. We have jobs board at jobs.adafruit.com. You can check out the latest job postings there. So far this week we have research technician in Rockville. So check that out. And we have some other CircuitPython related gigs, so check them out. If you are a maker or an employer, you can create a profile. It's free to do so. So check out jobs.adafruit.com. Cool. Okay, freebies. You buy stuff at Adafruit. If you spend enough money, you get free stuff. So let's head over to adafruit.com/free and take a look at all of the lovely deals that are ongoing while supplies last, right? So for orders that are $99 or more, you'll get a PermaProto half-size breadboard. For orders that are $149 or more, you get the PermaProto half-size breadboard plus a randomly selected stemma QT. If you have an account with us, we'll make sure that you don't get the same one twice. For orders that are $200 or more, you get the stemma QT board, the half-size PermaProto, and free UPS ground shipping for the continental US only. And for orders that are $299 or more, you get free UPS ground shipping, stemma QT board, half-size PermaProto, and it's Circuit Playground Express. You can get as many freebies as you want. Yeah, for every order. So that's the whole goal there. So check it out, adafruit.com/free. You can see some photos and some more text and details. They get automatically added to your account. And if you don't have an account yet, it's free to do so. Make an account with Adafruit. We promise not to spam you. That's my promise to you. There's guarantees in life, and one of them is Adafruit will not spam you. It's like death, and Adafruit won't spam you. And joining us is Fetty too. Hello. We're just posting all the links and stuff, but I think that's it for the housekeeping.
Let's see, running through the links.
Oh, I got one more. This super awesome milestone, 2,500 learn guides. super awesome. Did we tell folks who the actual guide was in
I
2000?
don't know. Shoutouts to Foamy Guy.
I think it was Foamy Guy. It might either be Foamy Guy or Katney with the MacroPad. So both of you could share the joy of being number 2,500. So super awesome. You can see a lot of little guides here from folks in the community. I can see Liz's turntable. I can see some stuff from Becky. I can see Becky. I can see our very first project, the little MIDI guitar. Oh, MIDI. We go way back with MIDI. The little keypad. It's so cool to see everybody's things there. So check out the blog post. We have a nice blog post about it. And shout out to all the dev teams that worked on the Learn system. It's evolved over the years, and it's really fun to see it getting more new features.
Yeah, check out the photo there and see if you can do some I Spy with the guides.
Yeah, I could see some iOS stuff, some Pokeballs. Like, what's going on there? That's cool. Yeah, man. So never been a better time to click on that little dice icon at the top and see all the random guides that pop up. But shout out to all the guide authors as well, and everybody for using the guides and checking them out and sharing them.
So glad you mentioned the dice icon. We'll use it as a segue into this week's Learn Guide.
There's a dice icon?
Yeah, the little randomized dice icon in
Learn.
Yeah. So it randomly
I thought there was a dice here. There's actual dice here. Like,
oh, the D20?
There's a D20, there's a D10. Just kidding. All right, well, back over to the Discord. Hello, everybody.
Good morning. Andy Calloway joins. And then Alvaro, 32. It's hanging out too.
Yep.
All right, let's go ahead and jump into the Learn Guide.
Okay. Yeah.
This week's awesome project.
This Learn Guide's been up there.
Cute.
Yeah.
Now the video's out for this.
Yeah.
So we get to promote it yet again.
Sure.
So cute.
So this is a collab project with Liz Clark, of course. Liz Clark is very known for party parrots. So shout out to Liz and Lamar really for coming up with the idea here. So you can go over to the Learn Guide, check it out. We're gonna look at it in a minute here, but I just want to do a quick little demo here. So this is a 3D printed little case, and it's got some Kailh switches, color TFT in the middle there. This is powered off the Kitty Cat board? No, the Kitty Paw RP2040. The RP2040 is a great chip because it's something we can get. So the code by Liz Clark, she made it so that it can kind of be two different things. It can be a USB HID kind of MacroPad to do shortcuts or whatever you like. And it's also a MIDI controller, so it's kind of doing two things. And in the code, you can switch between the modes. You can just set one to be true and one to be false, and you can play around with those. The color TFT here there's kind of two options. We have quite a few different displays, so coming up with the right one for this particular project, I'm using the 128 by 128 in this demo, and for the USB HID demo, I've been using the 240 by 240 display, which is a good idea to kind of compare them. Let's take out the MacroPad real quick, plug this in, and see if we can get a good. So we have two of these, right? And the only difference between them is the display. And there's a reason there. I want to show you the two different types of display and some of the things to look out for when you're picking a display for your project.
Wow, first, right off the bat, that is super crisp.
Yeah, and it's got like a perfect viewing angle. It's like a really wide angle. So the 240 by 240 is a great display with double pixels. Here you can see it's a little bit, the colors tend to shift when you look at it at different angles. So right off the bat, this just looks better and you have more pixels. But an issue arises where you are starting to run, if you're trying to do MIDI and a 240 by 240 bitmap, you're going to run into some latency issues. So in this one, you can see that it's a little slow, and that's because it's kind of doing a lot, and there's not that much RAM going on here. So that's what's going on there. And then this one, with the 128 by 128, it's not using so much RAM, so I'm able to kind of be a little bit speedy about it. So I guess what I'll do now is a little bit of a demo, if my things don't fall apart. So I have on my iOS device, I got a dongle here, and then this is just USB. So USB MIDI will connect to anything, any host that likes USB MIDI. In this case, it's a phone. So I have this GarageBand program. It's a free music making app. So I have a drum kit. And in the code, I set each one of these to be a different MIDI CC number. So right now it's doing a drum kick. I have some hi-hats. And you can see that it's keeping up with me, so that's pretty nice. Now, I can't be doing like super fast stuff like that, but you know, it's not too bad. Party parrot dancing. This is super fun. So that's a little demo of just showing how quick, performance-wise, you can get this with MIDI controls. So just wanted to share that. And I really like MIDI stuff, so that's why I'm kind of highlighting that, not really showing the USB stuff, because I like to show the music stuff more. So that's a quick demo of it. I guess let me take it apart and show it off here. I'm going to need a spudger tool, so I think I set it over here, yeah. All my tools over here. This is a snap fit enclosure, and coming up with the design was really fun, and I learned a lot. So to open this up, I got me a spudger tool because it's got really tight fitting. But here it's got two covers, the bottom cover and the top cover. So I can pop this out by getting my spudger in there and just freeing it there. And then you can start to see how this thing is built. So we got these cool little sweeps here. Or I call them sweeps because that's the tool, the feature that I use in Fusion 360 to create these. So these little grabbers snap fit into the sort of shape that's lined up here that goes along the shape of the paw print. This right here is just kind of flea fitting. This is a little bezel that is just sits over here, and the way it stays in place is because it fits the opening here on the top cover like perfectly. So it just kind of stays in there. I had to be really careful with the placement of this thing because you notice that this display particularly doesn't have any foam tape. So thinking about clearance, you want to be careful when you're modeling a case so that you're not crushing your display. So you can use 3D models in your CAD software to verify the clearances, which helped me out a lot. So that's how this bezel works. Okay, and then the toe beans themselves are actually little 3D printed keycaps. So here you can see I got some Kailh switches and these little 3D printed keycaps, toe beans, they have a little bit of a texture on them because they're printed on a textured bed. So if you're looking for that type of texture, you've seen us talk about the PEI textured bed, and that's how I'm able to get that effect.
I want to get in a comment here that Alvaro said that he likes the size because it's perfect for a pet to use as buttons. He knows people have trained dogs to push buttons to ask for water, food, and to play. So that's an excellent idea. How to turn this into some sort of pet, like translating device.
Yeah. I would have loved to have Rufio, our dog, play with it. He's just terrible with cameras. Like he just instantly knows. So if you ever see a photo of Rufio, it's a rare sighting. So yeah, that's how these are. I can just pop these off. They are, they're mirrored, but they are two different ones. So you can see there's these little toe beans and these bigger toe beans just to kind of match the aesthetics. This purple thing here is the plate. So these switches just press fit into them. And then I have 4 screws here on the tabs. I love this display because it's got these tabs. It makes it really easy to mount it. And there's plenty of clearances and stuff for it. So let's take a look at the bottom. What am I going to get in here? Like that. There we go. A word about the sweeps and stuff. So here's the board. Reason why I don't have a snap fit go along the entire thing is so that I can actually get the spudger tool in here. So it's a bit of a strategic thing. Also here you'll notice that there is no snaps there because that's where the USB port needs to be. And if I had a sweep going along there, it'd smash into the USB port. So that's why I have it open there. So here it is. I'm using silicone covered ribbon cable because there's a lot of wire connections going on here. There's about 8 wires here for the display. The display is a SPI. It's like over the SPI connection, not an I2C. So you have more wires here. But thankfully, the Kitty Paw has like just enough GPIO. I actually have 1 spare GPIO. So if you want to do the same project but with 5 key switches, you have that extra pin there to do so. You're probably wondering, why is this Kitty Paw mounted to this board? It's because I kind of did that on my own. I wanted a better way to mount and secure the Kitty Paw. So I came up with a little custom PCB. You don't need this, but I thought I'd make a little carrier board that would allow me to surface mount this thing, and this cutout here accommodates for all the components on the back of the Kitty Pie. And these tabs here are M3 screws. So that's what I got going on there, and the reason why it's this color is because it's been CNC milled. But let me take this key plate out to show you how easy it is to kind of take it apart. And there's some hex nut screws here, right? And it's pretty much flush with this. And adding a hole here for the display was really smart because now I can like I can feed the display through this giant hole, yet I can still use these mounting holes to secure it. And you can see here I got all my ground wires sharing a common ground, and I wanted to keep these two ribbon cables separate so I can tell them apart. This one's just the switches and this one's the display, right? So trying to stay neat here. But yeah, that's how this one is working. And then if we look at the frame, there is a little overhang here. You could do supports if you wanted to, but this is what it looks like without supports. Pretty decent. And here you can see there's a little ledge. See the little ledge there? That is what keeps the key plate in place, and it keeps it from falling into the frame. So the way you install it is kind of fit this over, and then just press fit that in there. Right? And then just want to be careful with your length of wires, right? I had to make sure that the length of cabling wasn't too much, but there is enough room in there for a lengthy cable. And then if you want to put this back on, you can just click this in here, and then just line it up. You start with one side and work your way on the other. And there you go. And then these toe beads can get press fitted in. These little stems are kind of a tricky thing to print. I found if you print like a batch of these, sometimes 1 out of 3 will fail. So just a little tip there. Maybe print 1 at a time and then work from there. So these get pressed in. They have about that much travel, maybe like 7 millimeters or so. And if anyone has any comments, Phaedra can tell me. I'll check in a minute.
Just a discussion on Alvaro's panda dog, as he calls him.
Yeah, panda dog. See photo panda dog. And then this one, let's go ahead and take this one apart too. The only difference here is the display. But the bottom here is something I want to show y'all because it has, if I could get it, what has this got like tighter tolerances here? There we go. This one has no custom PCB, and you see the Cutie Pie just kind of pops out of place there. So if you want to do this route without a custom PCB, maybe add some tack or something to keep it in place, because I do find that the tolerances get weak. I've taken this apart so many times that the tolerances just, they don't hold anymore, particularly for just the Cutie Pie. But the holder here is designed in a way where you can see there's a lot of components, not a lot, but there's components on the bottom of the Cutie Pie that you really have to be careful for. I've broken one tiny resistor, and like the entire board didn't work. So you really need to be careful with that. And I ensured that that there's proper clearances here in the little edge where it rests on, so that they're not being pressed up against anything. Like the components aren't being pressed up against anything that'll make them fall off. But yeah, the tolerances, it's okay, but sometimes it comes out. So that's the only difference there. And you can see here the display has the exact same sort of design. The way it's mounted is the exact same. It's just this one's a 240 by 240 display, but same like pinouts for sure. And just want to be careful closing that up, because sometimes that happens right there, where like the force will like pop out the board. So that's why I made a custom PCB, because I've gone through this route before, and it's just like very difficult to get something to stay in place when there's no screws, and that's why this is a really nice kind of thing. Yeah, shout out to was it Stuart Riggs who got one ordered. Yeah, he ordered this out and is integrated into his design. But yeah, you can grab this if you want from Osh Park. I'll put the link over there. But yeah, I'm really liking the this other version here, because all the custom PCB, and the display is a little bit, you know, faster because it's got lower pixels to handle. Yeah, so that's a kind of a look at the assembly, the case, some of the components. We'll walk through the guide now and just kind of see what's going on there. Is that cool? Any other questions?
I've been posting links to all of the guide-related material, like the code that Liz wrote, all of the STL models, all of the components to build, and of course, Learn Guide and the YouTube video. You guys want to check all those out later?
Yes, please do. It was fun to work on. This is one of those projects where it's like more fun to design, and the process of making it is way more fun than like actually using it. Right? Like this is one of the things. And I encourage folks to do that, like just chase some of those ideas that are fun to work on, not necessarily to finish. I'm sure it's fun to finish it too, but boy, was it more fun to work on it.
All right, let's go ahead and jump into the Learn Guide.
Sweet. So yeah, let's. The first page just has all the components. We have just about everything in stock except the Kitty Paw RP2040. I have no idea when it'll come back, but hopefully we'll have more in stock soon. Yeah, let's just say that. But the displays are in stock, so that's cool. It's kind of hard to get displays right now, so I'm really surprised we have these displays. And then some of the extra bits, the Kailh switches, you can pick whichever one you want. They're all going to fit. As long as it's a Cherry MX compatible, you're pretty good to go. Here's the silicone wire, and some other things is like the M25 kit, which is used for the display, and the USB-C cable, because why not, right? All right, so there's that. Circuit diagram has all the wired connections. This circuit diagram also works with that other display, the 128 version. It's the same pinouts, just a kind of a slightly different driver. But the wiring is right here, so you can see in the code you can kind of change up the pins, but this is what we have it set up for. So if you do use a different board, you just make sure your pins are reflected in the code. And that's pretty straightforward. But yeah, look at all those pins on the Kitty Pie. Used just about every one. There's one left right there, the miso.
Every bit of the Cutie Pie Buffalo.
Yeah. All right. The 3D printing page has some step files and the CAD source. So if you want to remix the design, you can download like a step file and use that step file to have the original sketches and the solid bodies, so you can really tweak them out. The STLs are great, but the original step file is like that's all the source there. Let's see. When it comes to slicing, there aren't really any new slicing techniques. Just be aware that if you are slicing the toe beans, aka the keycaps, you might want to just start with one first. And the STL is, I exported it as a group, so you might want to use the mesh tools in Cura to break the model so that you can print them individually. Or you can export them out in the step file or the Fusion 360 file if you want. But I thought folks would probably just want to print the whole set of the keycaps. Yeah, so try that out and use some slice settings here. You'll want to use your own slice settings if you have your filaments and your things dialed in. You'll want to use those, but these are the kind of standard settings that I use. And then for folks that want to completely remake their own keypad, we always have a link to our GitHub repo that has 3D models of our parts. So like the Cutie Pie board, Cherry Switches, the TFT display, those are all available to download in the GitHub repo. And the way it works is if you click on this link here, open a tab. GitHub's UI is always a little bit weird at first, but the way I have it set up is this main directory basically has a product ID, a PID, in front of the name of the product. So if you're looking for the MacroPad is 5100. So what I did there was I did Control or Command F for finding, for searching, and then I just typed in 5100, and then here it's highlighting the directory, the folder of where the models resides. You can see here I got a description, and it says 8 days ago. So if you click on that, here are the actual files that you can download. So the F3D is the Fusion 360 source. There's a GIF, there's a step, and there's an STL. If you click on the STL, GitHub actually gives you a render, a really fun preview that's interactive. You can kind of play with it. So that's fun. I never really talk about that, but you can just see how detailed the model is like the USB connector and the rotary encoder. Really, really one-to-one accurate models. So if you're doing something with really, really tight tolerances, even got the sockets in there. That's nice. And then you hit this download button here. It'll download to your computer, and you can upload it to whatever program you're using. But that's a quick rundown of how I like to use the interface in GitHub to get files. Yeah, so that's a quick look at that. I try to put this in all of our Learn guides so folks know that they're there. And I try to link these in the product Learn guides as well. So if you look at the Kitty Paw Learn guide, it should be in there. I try to add them as I go. So that's the 3D printing page. Next up, the CircuitPython page. This is going to show you how to, it's going to walk you through installing the latest version of CircuitPython onto your Kitty Paw board. So it just walks you through that. It's actually a mirrored page. We try to have a mirrored page in all the things so that if we ever need to change it, we just change it in one spot. So shout out to Katty for coming up with these mirrored pages and templates. Next page, this is by Liz. She has the code here, and we have the project bundle button here, which is great. It's a fairly new addition to the Learn system, where if you click this button, it'll download all the code, the images, and the libraries, and their dependencies, which is really important. So you don't have to hunt down the libraries anymore. You just click this one button, and you get a nice zip with everything in it. So that's really nice. But yeah, very heavily commented. Liz did a great job on setting it up so that we can change between the MIDI mode and the keyboard mode just by changing these true and false statements here.
Very nice.
And then there is some extra stuff here. I think our battery died.
Yep. It's fine.
Okay, should get that new battery. Here you can see the comments are talking about the key codes, and you can change these up. There is a commented here if you want to use like a control key on Windows or a command key on Mac, you can just switch between these. So that's really cool. And then the MIDI notes are right here, 60, 61. You can pull up a MIDI notes chart and find out exactly what note is what. The MIDI library just likes numbers, so that's why they're numbers and not like the actual the note like A3 or, is there an A3? E3, those type of things. But anyway, those are the MIDI notes. And you got some pinouts and stuff like that. Everything is just about commented, and on top of that, it's all broken up in the code walkthrough, which is really thorough, and it breaks all these things into pieces. So check that out. And here's a little screenshot of what your CircuitPython drive should look like. It should have a code.py file, your bitmap of the sprite sheet, the party parrot sprite sheet, and your library folders with the sublibraries in them. Cool, cool. Code walkthrough, it's like we were saying, it's all broken up here into little segments. So you can see here if you want to deep dive on all the different blocks of code and what they're doing, check it out. Excellent. Great resource for folks that want to do something similar, either with USB or MIDI and display I/O, right? Like doing sprite sheet animations and having them talk together. It's pretty cool. All right, so that's the code bit, the walkthrough. Wiring is pretty straightforward. We just got some photos here of wiring up the bits. You want to follow this because it's a bit of a chronological order. You want to kind of solder these things in place like that. Once your keycaps, once your mechanical switches are soldered in place to the key plate, well, they're not going to come out of the key plate because they're soldered in place, right? So that's one of the things here. Yeah. And yeah, it's just really nice photos of wiring it up here. And big fan of ribbon cables. All right, and then when it comes to assembly, same kind of deal-ish thing. Follow it chronologically. Here's some screws. Press fits. And add the toe beans, and we're done. There's a resource page if you want the circuit diagram. That's there too if you want that. We try to offer all of our circuit diagrams in our Learn guides. And if you want to create your own circuit diagram, we have a library of parts that you can grab from the circuit diagram page. There's a link here to the GitHub repo for just fritzing parts. So very similar to the my CAD parts repo, the fritzing parts repo, a little bit different. This doesn't have PIDs, but you can see here that we have just about everything. So that's pretty cool. You can download the whole thing or pick and choose them as you go, which is what I do. Yeah. I think that's it. In a nutshell, toe beans in a nutshell. MIDI kitty code, party parrots. Wow.
Yay.
RP2040.
Somebody is chatting about how to train your dog.
How to train your dragon.
Then Dexter was asking about how long does it take to go from concept to presenting the project on the show. I answered about 2 to 4 weeks. Depends on availability of the components, and then product launches also affect.
Yeah, it really did. We bounced a little bit back and forth between testing, like what should we do? You know, is it okay that it's slow? Is it okay that it's not the best display? So that took a little bit extra time to like really pick out what.
And then the product supply shortage too played a part in what products are available.
For sure.
What we can actually.
Yeah, these are the displays we have, and we only have one chip. So I mean, the chip's fine. We have lots of support for it. But yeah, about 2 to 4 weeks. Yeah, this one is a little bit quicker, I think, because there's not too much going on, right? You got mechanical switches in the display.
Going on.
Right.
Sometimes we have to wait for
right.
A
Like
product launch
the Kitty Paw RP2040 is mature. But what I mean by that is that it has a learn guide, it has demo code, it's been used in a few projects now, so that's good. But yeah, that's a good question. How long does this stuff take?
And then I lost my train of thought. There was
what were you gonna say?
Had to do with like just waiting for a product launch to happen, and then
which one, the MacroPad?
Yeah.
Like there's a project right now that it's another collab project with Liz. It's a 1x4 board, and I can't get the board. It's out of stock.
We're out of stock. All right, let's go ahead and jump into this week's What Are We Prototyping?
Yeah.
Speaking of projects that are in prototype and might stay there for a little bit.
We have 2 MacroPad things.
Do you want to do yours first?
Yeah, we'll do mine first. So last week I had a stand that was like a wedge. This week I was like, hey, we should do a print-in-place hinged stand. So I got this kind of frame going on, and then this little thing here. This is all printed in place, these 3 pieces. They have joints, so they pivot. And the idea is that you have this little thing swing up, and then you see these little dimples here? These dimples are closely matched to the actual button head screws here. So what it does is the button head screws just lay into those dimples, and it stays in place. So you get this really nice kind of wireframe looking inspired stand. And the PCB itself is mounted with these 4 M3 screws, and the MacroPad has these soldered SMD standoffs, M3 standoffs, so you get some nice elevation there, and it's super secured in there. But this is completely printed in place with no supports. It prints flat like that, and you have a couple of different kind of viewing angles. So you can kind of do it this way, or this can go this way, and of course this can go higher by setting it on those dimples. That's cool. What's funny about this is that like it is printed in place, but watch this. It just comes right out. I could have just printed it in pieces. So that's kind of how it's working. These little extrusions are at a 45-degree angle, which turns them into this sort of cone shape, pincher cone. And then these dimples here is what allows it to kind of snap in and stay in place. But because it's PLA and they're fairly not too thin, like you have a little bit of flex to be able to pop this out. So you could print this separately. Now this one's a little bit harder to take out because of the close proximity to where the joint is, so that's going to be a little bit hard to flex open. But I was able to get it open. I'm not going to do that now, but you can see how much range of motion you get with this sort of hinged design. You can go all the way out, or you can go all the way this way, just about a full 180 degrees. So what I'd like to do is add more dimples. If I do a repeatable pattern going across this way, well then what that allows you to do is to have an adjustable angle here, so that if this was closer, then the pivot would be less extreme and it wouldn't be so inclined. Or maybe it would. Maybe I'm not thinking about this right. Like if you keep going up, then it goes low, and that's too high.
That's not bad actually, depending on what angle, like the height of your table that you have that on.
Another problem I see is like these will just be slippery, and the thing that makes this stay is those dimples up there. So
I mean, you can have a rail that connects the
dimples, that's true. I could have a rail here. And yeah, I think the other idea is to have this stay here, and then there would be some notches here in the frame so that it could like adjust the notches down there. So there's some ideas there. I might do it, I might not. I don't know. Because I kind of like the simplicity of this one. And that viewing angle there is, I forget what the degree is, but it's in CAD. Yeah, and I think that's about it for the stand. Print to place, or you can print it in pieces. That's cool, right?
Always handy.
Yeah, and then I'm just still running the demo code, folks, sorry. It's just the demo code that comes default with it. I'll come up with something, but right now...
Nice little segue onto a guy that was just released by Phil Burgess. He has a hotkeys for Photoshop, or
that's great.
I think a couple other graphic editing programs. You can have like your cut paste, your what is it? Other keys that are used.
Adjustment layers. You can do adjustment layers. You can do levels, right? You can do export, say for web. I like using that a lot when I'm doing GIFs.
So when we go to the
import
Learn
video
guide,
to frames. I do that a lot.
doesn't work in the new one.
They killed that?
No, it's beta. I'm on that.
I was gonna say, like, what do you guys pay? What are we paying you for? Like Adobe, you're taking stuff away.
I gotta go into Media Encoder and export it that way now. Let's see. Phil Burgess has the macros for Photoshop and other graphics programs. So black and white, swap, eye drop tool, wand tool, move, marquee, redo, brush, erase, fill, and heal. And of course you can change those around. If you go to learn.adafruit.com, just released.
Yeah, we need to make this into a Midi controller because that's all I'm capable of. Sorry.
Cool. Lou on the YouTube chat asking when the MacroPads will be back.
Maybe
in
tonight.
Stock.
Maybe tonight.
Yeah, sign up for the alerts when they get back in stock, or leave the web page open and refresh like a mad person every hour. Yeah. It's actually what we do.
Don't tell them my secrets now. You can for sure tell them. Yeah.
Yeah, it should be a couple more going back in stock. Yeah, the way that these are made, they're produced in batches to make sure there are no bugs, so we can easily fix those out and swap them out if the bugs are severe enough. So that's why the stock was a little low.
All right, Pedro, now tell us about your keycaps.
Yeah, so Lamar had an idea to make this more accessible for people who have like hard of seeing.
Vision impaired.
Yeah, vision impaired
folks,
people.
yeah.
So of course we had to make some Braille keyboards with like the function keys on them. Specifically like copy, paste, escape, tab, volume up, volume down, home, end, play, pause, page up, page down, and quit. So it's a little bit difficult to see with the lights going on. You can kind of see them there.
There you go.
And these are all just looked up what the spacing and what each function character was for Braille. A little bit difficult to see on that, but you can see a little bit more clear on a opaque filament. So yeah, just taking what has been done with these stickers. I think, what was it? Putty, I think is the name of them.
Okay.
You can get those and attach them to your existing keyboard. So we just wanted to make some models based off of, what's the product ID for that one? These are the 10mm high ones that we have in the shop. So you can add that to these keys, or
they're
go ahead
symmetrical and flat.
Yeah, you can print out your own, or I'll make these available too where it's just the top portion, so you can just double stick tape or glue them onto your existing keys. And what's cool is Lamar wants, when you tap on each key, to have audio, since there is a speaker on the back. So you can practice your Braille, or a user can, have audible feedback when they press, the key that they're trying to get to. Or obviously you can feel for it, and then when you press it, it'll be confirmation that you did get the right one pressed.
Cool, yeah. Custom keycaps is a thing.
Yep, so the keycaps again, all 3D printed. There is some support material that is on the stem here. And if do a little comparison, there are multiple ways to actually model this. I went with the circular design for the stem, and you went with the square design.
Yep.
They both work.
Yeah, they do.
Tolerances came out pretty good on these. And that's because we spent lots of time, what was it, in 2016, making some ones for like resin printers and making our own keypads.
Sorry. Yeah, the thing about them, like, the printer really dictates like what kind of design you're going to have. I'll say that this one is printed on our Cruelty machines. This doesn't quite print well on our Ultimakers just because of like their nozzle type and
I guess
maybe the filament. Like literally, this is 1.75 diameter filament. The Ultimakers are 2.85 millimeter diameter.
I want to say the construction of them too, because these only print perfect on the CR V2s, and the V3 does not print well on the CR V1 or the CR10 Pro
V1.
Yeah, for whatever reason, maybe the Brailles are set up different.
I guess the takeaway here is like
something.
You should like design your own stem around your printer, around your filament, and your design. So you can use our design as a base, of course, but I think it's nice to create your own that we have full control over the smallest tweak or detail. And you can get crazy with your extrusion widths and your line diameter when you're slicing, so you can get a tighter tighter tool path when you're printing. It's a difficult thing. Yeah.
So in the chats, anybody got it? Let's see. Oh, Alvaro saying that the encoder would be good for adjusting white balance, contrast, and other goodies on raw images. Yeah, that is a really good idea.
Yeah. Okay.
Ending my pins there.
Yeah.
Yep. So these we'll release these once I.
This
next
doesn't
week or
have
something.
the plate. Okay.
Oh yeah, I didn't put the plate on there because I'm still messing with removing switches and testing out the spacing and like the print settings for them. So
yeah, good start though. That's great.
Yeah, pretty much done.
If folks want a 3D model of the MacroPad, this one here shows you all the pieces for it. So you have the back plate, the main PCB, and then the key plate, and then some extra components here: the OLED, the rotary encoder, and then the Kailh switches. The Kailh, sorry, they're Cherry MX switches, but they're Kailh sockets behind the PCB. And also the reverse-mounted NeoPixels are all a part of that. And USB-C connector, of course, too. So all the goodies are in there and populated. The board's fully populated. So check out that model. It's on GitHub. Yeah, I'm using this one for all the things.
Going in chats.
I don't have a clip for layer by layer, so.
I already posted the link to it.
Excellent.
It wasn't the spine. What was it?
Yeah. So this was it last week? Boy, I don't remember.
Sweeping snap fits.
Yeah. It's how I created the snap fit geometry for the keypad using sweeps, the sweeping tool inside of Fusion 360. Sorry. So check those out. There's a link. And there's also a playlist if you're interested in Fusion 360.
And I think that's it for prototyping.
Yeah.
Right? That's
I think
close
so,
enough to show off.
We're caught up here with what we're prototyping.
All right, cool. Let's go ahead and jump into this week's Community Makes.
Cool. Let me pull out some links here. Every Tuesday, we post a video of a 3D printed time lapse. This week, oh boy, that's not the. Sorry, Pedro. If I had links loaded,
This week is a very awesome toy marble machine. This thing is so cool. Print in place.
All right, here it is.
The joystick controls the. What is this thing called? Somebody in the chat. What is this?
A joystick?
Yeah, the joystick controls this, the base plate, which moves around this little marble. You have to get through this obstacle. Just
so fun.
I know. Yeah. And then, of course, what makes it fun is just knowing the way that this was constructed. It's all printed in place with this little bottom here that is controlling. It is being controlled by this joystick. So, like, no motors or anything.
So mechanical, man. Love it. This is really, really fun.
It's so cool.
Yeah.
Took a little bit of patience to print this out just because of how tight the tolerance is.
Yeah, look at that.
And the thinness of what is holding this the table.
So this entire assembly was printed all in one piece.
Yeah.
As one job. And then this too, or this is
No,
just
this
put
is
it on top?
separate. Yeah. So the who's the user? If you
Yeah,
go
it's
to
right
his
here.
Page,
I have this page.
has a couple of different. He calls them playgrounds. So you
This
have a
is,
couple of different levels, I guess, that you could print out to advance forward, or just be stuck on the same level because it's so hard.
This is Yanis Bruchalski.
Yeah.
Posted this up on Colts 3D. It's a free download, so check it out. There's some nice GIFs of it in motion here. Swappable mazes.
Yes.
That's amazing. So you can see here, completely different game, a different diameter of balls too. The marble balls here.
Yeah, you got to use
steel balls?
8mm ones or 4.
Yeah,
he says
this
he has
is
lists
excellent.
there.
Different colors too to go matching with it. This is such a fun like little analog game. Ah, so good. So check this out if you want something. Do you want to test the tolerances on your printer? You want to test out that new hot-end that you installed? This is a good one to go, and it's free to do so. And you can print that out.
It's
Very cool
and
mechanism.
His model includes a version that has the support materials already baked in there.
Ah, that's very
to make
clever.
for this long rod here that is connecting.
Right. Yeah, that long rod.
Yeah. Or that's holding it in place actually. So
Cool.
definitely go with that one.
Cool.
The supports are a little fused on this side,
Yeah.
so that's the only thing you got to watch out for.
You want to watch out for spaghetti. The attack of spaghetti. Here's the Timelapse Tuesday video.
Oh, yeah.
Featuring spaghetti.
Yeah,
Tell
so
us about the spaghetti.
So you definitely got to watch out for the horizontal expansion. I think I did like negative 0.2.
That's why it failed?
Yeah. Oh, and Z-hop.
Z-hop.
Because it runs into those tiny little posts.
What is
that are holding
Z-hop?
that.
Like a quick.
So it retracts your filament, and then your head, your nozzle head, lifts up to move over to the next part, so it doesn't strike or run into a previously printed section.
Hence the Z-hop. It hops to avoid crashing into the layer that it just laid down. I guess that's a good way to Z-hop. So you expanded the Z-hop? You made it higher?
No, I just turned it on.
You just turned it on?
Yeah.
Oh, it wasn't on at all?
No.
So
You
the
don't
nozzle
always
was
need
running
it.
into like a curled, a
Exactly.
geometry that's been curling up. It'll just boop.
Yep.
Wish you could like pause it
It's
right
like
there.
1mm for the Z-hop.
Yeah, that looks way better. Excellent.
Yep.
All right. So there's a little tip there on printing stuff.
And of course,
Z-hop.
what's so cool about it is, like, again, the mechanism that makes this all possible. And Alvaro's saying that he loves the physical joysticks.
Physical
This might be
joystick
useful
and just having a
for
modular.
remote operating on weird places like the inside of a guitar.
Oh shit!
Right?
That's super clever. Yeah, a built-in handler. Yeah, that's really neat.
Makes me think
I
of
love
like the Da Vinci machines that the doctors use to like operate.
Oh, that's funny. Yeah.
Yeah, it's really
Don't
fun.
use this to operate on my brain.
You know what I mean?
Yeah,
It's
yeah. But it's super fun
Nice
that you have
concept.
this modularity, right? Of the play piece being modular. It's really fun. I can see these marbles are too big, huh?
It is, yeah.
But it worked out. Like you did a really good job on the demo.
Oh, hey, check it out.
You
I
got it. This is so,
Yeah, I know, it's so much fun.
this is my first time seeing you play it too. I've been busy. It's so cool, man. So huge shout out to
Quite a
Yanis
challenge.
for
Super
releasing
fun.
this out for free.
And of course, the mechanics. You go, whoa, that's so
Yeah.
cool. Yeah, challenging.
Super fun. All right, we have more community makes to get to before we close out. We got 10 minutes left. I am loving these Mickey ears from Charlene. Huge shout out to
Are
Charlene.
so
Give me a second.
cool. I
Give me a
want to
second.
build one of these.
I'm going to build these.
When we get back for the fireworks. Wow.
Can I
So
copy?
we built one, I think, 2 or 3 years ago. These
Something.
were based on the
Probably-
little Mickey ears that you
probably
can
2
buy
years ago.
there. I like her idea of just using an existing hat, especially during the heat.
Yeah,
and
so
sun.
Charlene is a fellow Learn Guide author,
Yes.
and she does 3D printing and CircuitPython, and this project combines CircuitPython, 3D printing, and LEDs to make Mickey ears. So here's a quick
So
demo of it. And I really love the style of the thread here in Twitter because she shows her process of coming up with the design and the different iterations that it came up to. So very simple, minimal with reason here, because a lot of the time you're putting LEDs on something, you're going to blind people at night, and that's very not cool when everyone's trying to enjoy their time. That's why when we made ours, we made sure that the LEDs go these straight forward, right? So they're not bothering people. So this one, similar vein that it goes inward. And it's really cool. The original idea was infinity mirrors, which is such a cool effect too. But when she was making it, she was like, well, you know, it actually looks better without the infinity mirror because it's not going to be reflecting in someone's eye. And sewing it, you can see here some really close-up shots of the sewing part on a hat. Integrating into a hat is a brilliant idea instead of like...
Yeah, because you pick your own design,
your own
not
hat
the limited...
that fits you, yeah. The one we did was the Mickey ears because we just wanted to stay with like, hey, everybody's buying these damn things, so we might as well stay with that. But here's the enclosure, little snap fit action going on with the, I think that's an itsy bitsy, could be wrong. Maybe it's something else. And then just some things
Yanni
here.
says that she should switch them out for fans.
To
like,
cool you down.
Cool, yeah. Or at least the person in front of you or behind you or
It
something.
like tells you how hot you are. Like it's red when you're like burning up, and as you cool down, it turns blue.
I think the more important one would be the UV, especially.
Look how many she made. This is so amazing. She made
the whole
all.
family.
Yeah, the whole family gets in.
Yeah.
There's the whole family.
Of course.
So that's super cool. We only had 2, but hey, that's really great. So shout out to Charlene for sharing this with us, and yeah. So follow Charlene on Twitter for more inspirational projects.
Yeah.
Super, super cool.
I want to build some.
Yes, you do.
More modular than the ones we did.
Okay. Next one. This is another community make. This one is from Stuart. Stuart, you are watching.
This is awesome.
Yeah, this is... Stuart's been macro padding it up, so he has a couple base bits here, and I wanted to show the motorized one because like that's just next level.
So cool.
Yeah, is this the motorized one? I think these are just some additional
If you're deciding
pieces and stuff.
on what angle to mount your MacroPad at,
Yeah,
I'll have it controlled by a servo.
right. I think that's the next video. This is just kind of showing like some extra bits that snap into the sides here. So a really, really clever way to get your kind of base to have different modular frames. So your frame has those little indents, and then the base is what clicks into them. So it's a really clever approach to making a modular kind of multi-part assembly. But Stuart's motorized MacroPad is just next level. If I can pull it up here. Oh no, I think I might have lost it. Maybe it's under media. Here it is. Get ready for this one, folks. I'm not sure where the motor is. I'm thinking it's a servo, but the button here is like, doop. So if you want like a motorized angle, flat, and then a little bit slightly angled, so it's super cool.
I feel like one of those rising desks. You stand
Right.
up.
There is
sit down,
an actual commercial, a mechanical keyboard that has that built in. A fellow on Twitter tweeted that out to me. I was like, oh, that's crazy. And then here comes Stuart, like, I did it. It's just like, poof. Super, super awesome. So follow Stuart on Twitter too if you want to see more of his stuff.
Yeah, he's going to have a ton of really good ones.
Yeah, yeah. All right, we got one more for you folks before we close the show. This is a bit of a past one. Look at this one. This is NeoPixel LED gas mask.
You know what? Halloween is not
right
too
around the
far
corner.
off. I think
So
I
shout
saw
out to
Phil be posting that Spirit Halloween is getting ready to get all their stores open. So
yeah, they're
perfect timing.
setting it up. Yeah, so this is
so good.
I know. I love the aesthetic here. So Steptronics posted her make of the LE wire / NeoPixels. It was so fun to make this thing. I think I made it in 123D or maybe even Tinkercad. But yeah, you got NeoPixels in the center here with a nice 3D printed diffuser, and then you have this EL wire that's kind of wrapping around the conduits and stuff to make it just look stellar. A little bit of a Star Wars / I don't know what other inspiration from the gas mask, but super fun. And it's always a fun time I see folks making them. And this was printed on the Cruelty Ender 3 Pro, I think. And the comment here says, made the thing, build it with the 16 LED ring, the blue LED wire, a LiPo, and an EGAL LED. Super, super cool. All right, that's this week's Community Makes. Thank you everybody for sharing your makes with us.
Oh, amazing.
All good stuff. Cool.
Posted the links to all of those in the Discord. YouTube is having a heart attack trying to post these links.
Woo. All right, well, if you'd like to share your projects, what you're working on, we invite you to come on the show and tell tonight. We do a show and tell every Wednesday, hosted by Lamar and Phil. sometimes us or sometimes JP, but I think Lamar and Phil tonight. It starts at 7:30 p.m. Eastern Time. It's on the YouTubes, Facebooks, and the same places every broadcast. And you'll want to be in the live broadcast chat room when PT posts the StreamYard links. You can click that link, and you'll have your camera and microphone ready to show and talk, to show and tell. There you go. So you've been watching 3D Hangouts. We do the show every Wednesday at 11 a.m. Eastern Time here. We have lots of other shows too, like tonight, Show and Tell is the saying, but also Ask an Engineer is at 8 p.m. Eastern Time with Lamar and Phil. Get some open source hardware news, new products, and more. JP's Workshop every Thursday at 4 p.m. Eastern Time. And Deep Dive with Scott on Fridays at 2 p.m. Pacific Time. We're all over the place.
Week starts with Desk of Lady Ada on Sundays.
Yeah.
From 8 to about 11 to 10 p.m. Starting time.
Yeah.
Runs for about an hour, and it features the popular segment,
The Great Search.
Great Search, for
With
all
DigiKey.
of the replacement parts that has to be done with all the part shortages. So it is definitely one not to miss.
For sure.
That's right. Sponsored by DigiKey.
That's right. Mondays are CircuitPython meetings. Tuesdays is JP's product pick of the week. Every Tuesday at 4 p.m. Eastern Time. You can get up to 50% off the thing that's on
Crazy.
sale, which is crazy. This week was e-ink.
Yeah.
Inky. Excellent. And then cycle back over to the Wednesdays where we have like 3 shows. You know, Wednesday is a show day, but it seems like every day we have a show.
Yeah. And that's
Cool.
going to do it for us. Join us later tonight. But until then, make sure to make a great day.
Make Kitty Day. Bye, folks.
See you later tonight.
See you tonight.